So next we have an amazing speaker, another amazing speaker that speaks pretty much at every KubeCon, and I'm very excited also because I'm CNCF ambassador, and the project that we're going to talk about next, Opentelemetry, has been recently joined the CNCF as a sandbox project. So I'm very excited that we have this talk, and also excited that there's no more CI/CD talks because I'm kind of getting tired already from all the CI/CD we had today. But it was amazing. Like, we probably covered everything possible in CI/CD world. So, Steve, welcome to Montreal. You from Silicon Valley, I believe?
Yeah, both coasts, East Coast and West
Coast.
Yeah.
So, Steve was behind the startup Omnitron and Omniscient, sorry, and
that's a hard name.
Really pushing hard open census, Opentelemetry now, and the company has been acquired, so it seems like you guys did a good job over there. Congratulations.
Thank you.
All right, so it's all yours. Go ahead.
All right, thanks everyone. So this session is going to be on unified observability using Opentelemetry. I'll talk a little bit about the prior projects as well, including Open Census and Open Tracing, and how Opentelemetry came to be. In order to do that, first I'll introduce myself. My name is Steve Flanders. I'm head of product and experience at a stealth startup called Omniscient. We were recently acquired by Splunk. We're in the distributed tracing space, and we've been active contributors with Google and Microsoft on both Open Census and now Opentelemetry. So in order to talk about observability, I need to talk a little bit about the switch and the switch over to cloud services and microservices-based architectures. Most people have already done that today, so I'll be very quick with that. Then I want to talk about distributed tracing because it's very critical as you move to a more microservices-based architecture. And then finally, Opentelemetry itself. So as many of you know, if you're here, we're kind of moving to this cloud-native world. Well, what does that mean? Well, it basically means that we're moving to more of a DevOps model. We don't have separate ops and development teams. We're kind of working together, and it's dev's responsibility to ensure that things are operating correctly, and ops' responsibility to make sure that infrastructure is kind of treated as code and very automatable and repeatable. In order to do that, you have to automate all of this through a CI/CD system. We've heard several talks today on CI and CD, so you can kind of see the importance of it as you're rolling out your software architectures. Then we have this switch from monolith to microservices-based architectures. And there's a lot of good reasons to do this. There's a lot of good reasons not to. For example, a lot of startups will probably start with a monolith, and there's good reasons to do that. But there's also compelling reasons to decouple this so you can scale better as your team gets larger or your application gets more complex. There's also some pain points that are introduced as you move to microservices, and I'll talk about that shortly. And then finally, we have the move to more containers from typically virtual machines or bare metal systems. You now see a lot of containers, and of course, the move to serverless as well. So I mentioned that there are some pains in the microservices world. This is where my talk will kind of differ from some of the others that talked about microservices. What are those pains? One of the biggest ones is, how do I observe my system? In the previous generation where I had a monolith, typically I didn't have to worry about, like, how do I find the root cause? Well, it's in the monolith. I just need to go through my code and go figure that out. Or who do I wake up? Well, it's the monolith. I just wake up whoever is on the monolith team or whatever component is having issues. Or what is the business impact? Well, if everything runs in the monolith down, well, my business is down. It's kind of trivial. But in a microservices-based world, this is a lot harder. Like, just because one microservice is having an issue, what happens if that causes upstream and downstream issues to other microservices? How do I handle that? How do I know what the business impact is if it's 3 or 4 tiers down from the end user who's actually experiencing that error, and maybe it's being consumed and not propagated upstream to them? This becomes a very hard problem, and that's why you see this shift to what we call now observability, the new fancy word for monitoring. So in the previous generation with monitoring, typically you had just metrics and logs. They were great. They're still very powerful today because they can tell you point blank what happened and give you an audit trail of kind of who made what changes where in your environment. From a monolith perspective, this gave me all I really needed to know. It kind of pinpointed the problem within my monolith. But in a microservices world, these two symptoms-based tools are missing context. They don't know why something happened, and they can't correlate that information. An end user is then forced to do this themselves. Typically, that's the on-call person. Maybe it's the SREs that are involved. But it's much harder in a microservices-based world. So you may have heard the term 3 pillars of observability. That third pillar, tracing or distributed tracing, that's really one of the most important things when it comes to this new microservices or cloud-native world. In my opinion, like the 3 pillars, really distributed tracing is the foundational pillar of everything because it provides all the context and the correlation that you need, and it can actually enhance metrics and logs to give you rich insights as to what's going on. Distributed tracing can help pinpoint where a problem is occurring. It gives you the problem isolation aspects, and then you can use traditional metrics and logs in order to pinpoint what caused that problem, whether it's a regression, and how to actually fix that problem, whether it's reverting or a new code push. So the power of distributed tracing. If in the open census world, we use this hipster demo app. This is just a visual topology of what it looks like from an architecture perspective. Opentelemetry will likely use the similar hipster demo app. We just haven't moved it over yet. But basically, this is a microservices-based application. You can think of it maybe one similar to that you're running. And it's a polyglot architecture. So every rectangle here represents a different service. And you can assume that it's written in a different language. So Java, Go, Node, Python, whatever. This runs the gamut here. And you have different persistent backends. So a lot of people are kind of curious, well, if I'm not used to distributed tracing, what does that kind of look like? Well, really, it's a request or a user flow through your application, through the different microservices tiers. So in this particular case, where I basically have a web store where I can kind of check out and buy things from this hipster demo application, maybe a user comes in and they hit the front end, and then they have something in their cart, and they wish to check out the items in their cart. So sort of like the AWS or Amazon model. And then as I check out, I need to enter payment information. I need to go ahead and check the currency depending on which region I'm checking out from. I need to probably provide some sort of email to get the confirmation about the transaction that I'm making here. And then, of course, I need to ship this information out to the users so they receive their whatever items that they have purchased from their cart. This is one user request through this particular microservices-based application. That is basically what a transaction is. That's what a distributed trace can capture collectively. So just quick show of hands. How many people are running microservices today in production? About half. And I know someone asked this earlier. How many people are running distributed tracing? Very few hands, right? So a few in the back corner. That's great. So this is interesting because I can see that there may be problems in this environment, but it may be hard to pinpoint it. And I'll show some clear examples in a second. So this is one way to visualize a user transaction through the system. Another way is through more of a common distributed tracing tool. So if you've used something like Jaeger or Zipkin before, which are open source distributing tools, they provide kind of this water flow view. So this is the same visual depiction that you just saw in the previous slide, but in a distributed tracing tool. You can actually see the user request flow here. The front end calls the checkout, calls the cart, currency, shipping, payment, email, all the way out. You can also see some SLI or service level indicator information, like how long did each one of these steps take? How long did I stay in that particular microservice? If they were errors, they'd also propagate here. This is some rich insights because it can help you track performance regressions, or if there are errors, it can help you tell you where the errors are occurring in your environment. If I were to take this up one level, so if I take it out of a distributed tracing tool, this is basically what it looks like. I basically have a transaction or a user request. That's the A here. It represents one flow through my microservices-based architecture. Then typically B and E is what you'll see next, microservice to microservice communication. That's the most important piece because that actually shows me my entire flow and can give me problem isolation into the microservice that is experiencing an issue. And then if I really care about it, I can actually drill into my microservice and get down to functional level instrumentation, and I can actually trace every single call within a microservice as well. In distributed tracing terms, each one of the rectangles here is a span, and then the entire, all the rectangles combined represent a single trace. Every single user request would have its own trace throughout your system. So I mentioned that distributed tracing is kind of important compared to, say, metrics and logs in a distributed architecture. Why? Well, let's look at some classic examples. So I'm going back to the hipster demo store here. Let's assume that the checkout service is receiving a high amount of CPU. And in my environment, I've configured an alert for this. So the checkout service team who's on call gets paged. High CPU utilization. This is a metric that I can get in any of my metric tools. If you're using like Prometheus, very easy to alert on this. So now I know something happened. It is a symptom in my environment. I don't know why. I don't know the business impact. All I know is that I have this symptom. I can go look for other symptoms, but they're not stitched together. Well, it would be really useful to know that not 5 minutes ago, a new code push was made to the front end, and now 5x the number of requests are being sent to the checkout service. I wouldn't know that from my metric tools. I might have another dashboard that actually shows me information about the front end, and I might see the number of requests, and then as the on-call person, I'd have to have some domain expertise and actually map together and figure out that these two things are correlated to one another. But metrics alone, they just provide you symptoms. Distributed tracing can actually stitch this. Another example would be from a logs perspective. Let's assume now that the checkout service has an increase in HTTP 503 errors, so they get paged. At the same time, the email service has an increase in 503s, they get paged. At the same time, the front end has an increase in 503s, they get paged. 3 different teams getting paged. Let's say it's some holiday and you're sitting with your family. Do you really want to get paged if it's not your fault? No. Do you want to get paged at all? Probably not. How many people are on call? Oh, not enough. That's unfortunate. How many people have experienced this pain before? There we go. Yeah, of course. This is not pleasant. In a microservices world, usually when one microservice has an issue, upstream and downstream microservices also have an issue. But they're usually not to blame. There's usually a root cause. So in this particular example, it's actually the email service that started generating an increase in 503s. That error was propagated out to the checkout service, which didn't generate any 503s. It just propagated that 503 to the front end, which didn't generate any 503s, which just generated that up to the end user. Well, that means the email service team should be woken up to go figure out what's going on with them. And the other 2 services are fine, so leave them alone. Don't wake up those people. Again, if you had that context that distributed tracing provides, you'd be able to do things like that. So with that kind of background, let me introduce Opentelemetry. Opentelemetry is looking to do a couple things. One is it wants to have open standards for the collection of telemetry information and open source data collection, again for telemetry. Opentelemetry is actually the merging of 2 other projects. This was announced at KubeCon Barcelona earlier this year. It's the merging of Open Tracing and Open Census. They were 2 independent projects. They are now forming to join Opentelemetry, and the goal is to sunset both Open Tracing and Open Census. So long term, you'll be wanting to move to Opentelemetry. Google, Microsoft, Omnition, Lightstep are big contributors to all of these projects and are pushing forward kind of the Opentelemetry roadmap. And if you're going to be at KubeCon San Diego, anyone going to KubeCon? There's going to be a lot of cool announcements. If you haven't signed up for the Observability Summit on Monday, I highly recommend that because we'll be talking a lot about Opentelemetry. But really, this is the future of data collection of telemetry data. It'll be an open standard that will be adopted globally, and you won't have a lot of confusion of, do I use Open Tracing or Open Census? Use Opentelemetry. That's the one that you use going forward. So if we look at cloud-native telemetry, we talked about the 3 pillars of observability. We like to call those telemetry verticals in the Opentelemetry terminology. Those are your traces, metrics, and logs. But there's also different layers to this that are very important as well. You have the instrumentation APIs. This is something that Open Tracing was notoriously known for, specifically in the tracing aspect. You have the canonical implementations, the data infrastructure, which includes data collection aspects, and then all the different interop formats, including the W3 standard that's coming out very, very soon for distributed tracing and trace context. As you can see, for each one of these verticals and layers, some of them are language specific. So if you're in a polyglot architecture, you'd have to solve it for every single language that you care about. Some of the infrastructure things have different deployment models. Can I use a sidecar because maybe I'm in a container world? Can I use a daemon set? I'm in Kubernetes. Do I have to run some sort of separate agent on the host because I'm in some other deployment model? What does that look like? And then, of course, different wire formats. All of this is what Opentelemetry is taking on, the full gamut. So the goal here is to provide all of this long term. The initial focus is really on tracing and metrics and to be fully compatible with what Open Census and Open Tracing already had. But long term, this is also going to move into the logging space as well and provide an end-to-end solution that anyone can use. The goal here is a vendor-agnostic solution. It shouldn't matter whether you're running your own backend that you're going to be storing any of these verticals from, or you're going to be sending it to a different backend of your choice, maybe a commercial backend. This will be fully compatible across the board. The goal is to make it so you can very easily change the configuration and deploy things where you care. So there's really two key components to this. The first piece is the client libraries. How do I actually instrument my application for things that I care about, specifically traces and metrics? I'll cover tracing because it's a little bit more interesting. Metrics, I mean, you can use Prometheus. It's fully supported. There's no reason to do anything different from the metrics perspective. In the case of distributed tracing, if you're already using an open source library like Jaeger or Zipkin, that is fully supported by Opentelemetry, so you don't really need to do anything. But long term, the goal is to use Opentelemetry client libraries as the de facto standard. In fact, Yuri from Jaeger has already posted a blog post stating that long-term the goal is to get off the Jaeger client libraries and to move to the Opentelemetry client libraries when they become available. In terms of these client libraries, there's really 3 primary steps. Number 1, add a dependency on Opentelemetry. This would include choosing a context propagation format. W3C is coming out with a standard. Long term, that'll probably be the one that you want to use. Most people use Zipkin's B3 format today. You instantiate a tracer. A tracer is how you create traces and the spans that are associated with them. And then you need to configure a destination and where you want to send that. Opentelemetry has a collection mechanism that I'll show in just a second. That's probably the destination that you would choose. Next, you want to enhance your spans with rich metadata. So out of the box, distributed tracing can give you rich SLIs for requests and errors and latency information. But if you want to go beyond that, if you want to answer questions like, hey, what's the difference between my previous build and this build? Am I having an issue in that region or in this region? Is there a certain Kubernetes pod that is experiencing problems that other pods are not experiencing? That needs to be tacked on, enhanced metadata, into the spans that you're generating in your application. You can also tack on log messages. Now, of course, you probably don't want to have a ton of logs inside of your spans. Typically, you're going to tack on just your error logs, because from a troubleshooting perspective, that has rich information that your developers or your on-call will need in order to fix the problem at hand. Finally, you add more spans. So most people will start with service-to-service communication. They want to be able to determine whether a single microservice is at fault or not. But over time, a software developer or service owner of a microservice may want to enrich it with functional level instrumentation to determine which function call is having a problem. This is more common in like performance analysis if I'm trying to test like performance regressions between builds. But it can also be used for troubleshooting as more and more people or other services depend on your microservice and you want to see those interdependencies as well. There are also some interesting things as you start calling out to like external persistent database stores or you have asynchronous calls. Those types of things are typically handled after the fact as well. The flip side of this is the Opentelemetry collector. This is how you collect all the data that your applications are generating. So today, we actually provide 2 different deployment models for you. We have an agent that you can deploy with your application, either as a binary running directly with your app, as a sidecar running next to your app in the container world, or as a daemon set that you can deploy into Kubernetes and run per host. So typically, you would have your application send to the agent. The agent, in turn, sends to a collector. Usually, you run a collector per data center or per region, so you can keep your traffic local, and that collector can send to one or more different backends of your choice. As you can see, there are a lot of options here, and it's a very extensible backend. So all the open source ones are supported natively. So Jaeger, Zipkin, Prometheus, soon StatsD are all going to be natively supported by the Opentelemetry collector. Also, third-party vendors also provide their own exporters, and they provide support for those, so you can send to different backends as well. This works for both traces and metrics, and in Opentelemetry collector terminology, we basically have the notion of receivers, what applications are sending to us, and exporters, where you're actually sending that data to. The collector is really cool because you can actually send to 2 different destinations or 3 different destinations at the same time, and so it makes it very easy to actually switch vendors if you wanted to. As I mentioned, the whole goal here is a completely vendor-agnostic solution. That's something that the collector can provide. In addition, another reason why you might want to consider the collector is because it can offload responsibilities from your application. If you have client libraries and you're actually taking dependency on that, there are things like batching, queuing, retries, encryption, compression. Do you really want to handle that in every single one of your language and have your application handle that overhead? Probably not. So you can offload that to the agent and the collector. It can handle that, and your application can just worry about generating its traces and metrics and sending that on to the collection framework. So with that, I'll switch over to a couple quick demos and quick starts. These are extremely quick because I recorded them ahead of time. I knew that we'd probably be running a little bit close on time today. So first, for Opentelemetry, just a heads up, the Opentelemetry client libraries will be coming into alpha probably by the end of October, so very, very soon, but they're not ready for prime time yet. If you're just starting with distributed tracing, you probably want to look at OpenCensus or Tracing to get started, but do note that by the end of the year, we will have GA versions of these client libraries ready, and there'll be more announcements at KubeCon, so long term, you'll be wanting to look at this. I've pulled up an example of Opentelemetry client libraries for Python. So as you can see here, it's pretty easy. I import the tracer from the Opentelemetry trace project, and then I just start a span, and I can create a parent span or a child span. It's really that simple. That's how you get started. Now, of course, long term, there's more work to be done here. I talked about tacking on metadata like build information or key value pairs that you care about. You'd have to add that as well. But as a quick getting started, just generating these traces is all you really need to care about. One important thing to note about generating traces in your environment, context propagation is probably the most important thing. I believe this was mentioned in an earlier presentation. You have to pass headers around, like in RESTworld or gRPC, you need to be able to pass around the metadata of these payloads because they contain like the trace ID that's necessary to be tacked on to the spans that you're generating. Next up, we have the Opentelemetry collector. So this is YAML-based. I'm really sorry. Even if you're not in Kubernetes, you have to use YAML to configure it. It's just the way that it works. But I think at this point, most of us are used to YAML, whether you like it or hate it. This is made up of receivers, like you saw on the previous slide. Here you can see I've enabled an OpenCensus receiver. Exporters. Here you can see I have multiple exporters. I have a Prometheus one. I'm logging locally. I'm sending to Zipkin, and I'm sending to Jaeger. So again, very flexible, and it's just a configuration change on where I want to send that data. And then there's the notion of processors and pipelines. So I mentioned that the collector can actually offload a lot of the responsibilities that client libraries would have to do otherwise. This includes batching, retries, compression, encryption, all of that. We call those processors that you can enable. And then you basically build a pipeline. I want the OpenCensus receiver to export to logging, Zipkin, and Jaeger while doing batching and retries. I mean, you can configure these as you see fit. There will be default pipelines built into the collector, so you don't even have to worry about this. If you're just sending to one destination, you just configure that destination, and you're done. Why is all this powerful? Because once I start collecting distributed tracing data, I can do really cool things like this. I can build a visual topology of my environment. I can get rich SLI information. I can determine where errors are, where there's high latency. Any tool that collects distributed tracing data is capable of generating something like this. Jaeger has an equivalent, Zipkin has an equivalent. This is really powerful because now I have aggregate information about my environment that I can use to troubleshoot both availability and performance problems. It's quite powerful. I highly recommend looking into it. And then finally, one of the cool things, or one of the things that's becoming more common in distributed tracing is this notion of sampling. The OpenCensus collector, and this might be a little bit hard to see, we actually have a demo app that's written in a Docker Compose file. It's on the GitHub repository. What this does is actually spins up 2 different Jaeger instances. It makes a Cassandra backend, and it has the hipster demo app running as a load generator. It will send load into both these Jaeger instances using the collector, and it can actually split the traffic. So we've configured a sampling policy that says 100% of traces go to one Jaeger instance, and only the error traces go to the other Jaeger instance. Of course, these tail-based sampling policies are customizable, so you can run a different policy if that's what you care about. It's really easy to get this up and running. You can edit the YAMLs as you see fit to see if it meets your requirements. It takes about 30 seconds to come up, so it should be ready here in just a second. And then you can actually see that the Jaeger instance on port 17,000 receives all the traces in the environment. So you'll see it'll have all the demo app here in 1 second. Here we go, 10 services. So I'll go look at the cart service. You'll see that there are traces coming into this for the cart service. Great. And then I'll go over to the other Jaeger instance, which is running on port 18,000. Again, the Docker Compose file handles this for me. I'll go look at the cart service again, and you can see I only received the error traces on the second instance. This is very powerful because most distributed tracing tools do head-based sampling, which means you lose useful traces. A head-based sampling policy happens when a trace is created on the original request, not what happens at the end of the trace. So if a downstream trace actually, or a downstream span actually has an error, you would lose that in head-based sampling. With tail-based sampling, you can actually pick that up. It's quite powerful. And with that, I'll wrap up. So there's a lot of cool sites here with useful information. I linked to both Opentelemetry, OpenCensus, and OpenTracing. I have the GitHub projects on here. Everyone is encouraged to contribute. There's lots of tagged GitHub issues, including Good First Issue or Help Wanted. Please definitely get involved. For all these projects, we actually leverage Gitter extensively, so take a look at the Opentelemetry Gitter room. You're welcome to join, and you can get involved with some of the SIGs. There is a governance board for this. It is based on the same CNCF Kubernetes governance process. So take a look at the community site, and you'll get a lot of rich information about how you can get involved. And we'd love to have you contribute as well to the project. Thank you so much.
Woo! Thank you, Steve. That was like sham wow.
I know, right?
Yeah, we wish you good luck. Opentelemetry, hopefully next year we can bring it up to the level higher.
Yeah.
And then hopefully graduate it, right? So thanks, Steve. We'll see you at the dinner.